Good day and welcome you all to the channel Loss Prevention Maverick, the intent of which is to explicate fundamentals on process safety and loss prevention. Today we will be talking from the workplace safety side. We will be talking about life-saving rules, and from process safety, of course, the process safety fundamentals. This video is a little different from the other contemporary videos that I make. Why? Because we would not be talking about these, that is the life-saving rules and the process safety fundamentals, but we would be using a technique called as mind mapping or brain mapping to further understand them, reconcile, remember, and make it more relevant. We will get to know as we pass on from the video. A little bit about me. I am Rahul Pateri. I've got a master's in process safety and loss prevention from the University of Sheffield. I've got a bachelor's in fire engineering. I'm a functional safety specialist working in the field of major accident hazards for more than 1.5 decades now. Started as a firefighter, got an opportunity to work for onshore and offshore engineering companies. Moved on to work into risk and reliability, and now working as an operator for onshore and offshore. The life-saving rules would be as per IOGP, and process safety fundamentals would be as per EPSC. Details would follow. IOGP is oil and gas producers. Bear with me, please. The link, I'll be leaving it in the video description, which you can go on and understand about what IOGP does, who all are the partners of IOGP. So the bigwigs in the oil and gas industry, they sit down and sort of analyze the root causes or the underlying causes to what leads to fatalities and hypo means high potential near misses. And statistically they came down to state that there are 9 such factors which, if controlled, can prevent fatalities and high potential near misses. Using this information, IOGP came down to what we now say LSR, the life-saving rules. So these are the 9 rules which say, if followed appropriately, that is the rules to be followed while bypassing safety controls, rules to be followed while being in a confined space and working over it, rules for driving, rules to prevent us to be in line of fire, rules to perform while we do hot work, energy isolation, rules for safe mechanical lifting, rules for work authorization, and rules for working at height. So what is claimed, or rather what is anticipated, is that if these rules are followed judiciously, transmitted and understood by the work performers or job performers, the possibility to have workplace hazards, fatalities, to be honest, workplace fatalities and hypo near misses can be prevented or reduced. So it is always said, how do we remember these 9 rules? I mean, when we from the process safety and loss prevention department try to bring it up in our campaigns of life-saving for workplace hazards or during training practices, is always taught to us, yes, it's all good, but how do we remember it? And that is something which our senior management in a town hall meetings and all has been brought out, like, fine, how can this be made possible for the common public, for the blue collar, the white collar people to remember? And this is where got us thinking, and that is where I am very excited to bring this video, is about using mind mapping. What is mind mapping? Like this picture shows, it is trying to correlate our need with our daily activities. So for example, let's see how can we memorize these 9 life-saving rules with basic day-to-day functions that we see, feel and hear. Okay, now, yes, this is Keanu Reeves, the movie Matrix, and talking about Matrix, this is a tic-tac-toe game, or this is a 3x3 matrix. To the left we see popping A, B and H. So what is Alpha A, Bravo B and Hotel H? It is activity, behavior and hazard. So we see a 3 by 3 matrix and activity, behavior and hazard. Now let's see how we can map the 9 life-saving rules with the daily functions or activities that we see. In terms of activity, now think about a person who is working at height. He loses his balance and uses the control, missteps, and then falls to a confined space. Fortunately, the fall was not too bad. He didn't break any bones. He's all okay. His motor control is fine. So we go on, ask someone to use a mechanical lifting method to lift the person from the confined space. Now let's see if the magic can work of mind mapping. In terms of activity, see, we saw about working at height, and that person who was working at height falls to a confined space, and we use the lifting mechanism to lift the person up. So the person who was working at height fell in a confined space and we lifted him. Now using that approach, let's see behavior. And while we talk about behavior, possibly all of us who always crib in the morning is about traffic and driving. So about driving, and this particular erratic driver who was in a hurry tried to bypass the traffic signal which was on red, and he went on, and what happened? He met with an accident which is also called as a line of fire. Now using mind mapping for behavior, the person who was driving, he bypassed the safety control and then hit with a line of fire. The next one is about hazard. Okay, here I would like to now have a Q&A with all of you all who's listening. So what are the hazards in an oil and gas industry? Yes, there is always a hazard of ignition, so that is hot work. There is always stored energy and electricity, so that is energy isolation. And these hazards of hot work and isolation, for people who work on the workplace, really understand that one of the administrative controls is using a work permit system or a work authorization system. So may I please ask all of you all to please pause this for a movement and just think about mind mapping. Think about how we use the A, B and H, that is the activity, behavior and hazard, to bring out the 9 by 9. Try to use it and try to challenge your memory, and please write down into the comments of this YouTube video on how much you got at the first time. And this is for life-saving rules. Let's see the others as we proceed. So moving on from life-saving rules, moving on from the mind mapping principle of identifying the 9 life-saving rules, and I'm pretty much sure that most of us, or a large majority of us, would have been very successful in remembering all the 9. Now let's come to the process safety fundamentals, and primarily about process safety fundamentals as established by the European Process Safety Center, the EPSC. This is the link which I will also leave it in the video description, so that you can go on, read about them, what sort of campaigns do they have. They have a lot of good booklets on the subject. There are training videos, all very self-explanatory and very easy to understand. But understanding is one thing, the other thing is about remembering them. So we would come to it a little later, but let's now see what is process safety. The definition of process safety in very simple terms is about avoidance of the loss of containment. Or rather, what is supposed to be in pipes or in a containment, let it be there, let it not come out. EPSC is a council or like a committee. What they did is that they looked into around 1000 to 1500 tier 1 incidents. Tier 1 incidents is that there is a major fire, explosion, a release, or multiple fatalities that happened because of a process safety event, and they identified three things to be done religiously and tactfully if followed could prevent occurrence of tier 1 incidents. So the three areas that they actually considered are: one is about operational excellence, second mechanical integrity, and engineering design. Operational excellence talks about what it talks on how operations or operators need to tactfully work their operations such that there is no loss of containment. Mechanical integrity, so that once your plant is functioning and running, what all inspection, RBI programs, IOW, integrity operating exceedance windows, have to be considered so that your loss of containment doesn't happen. And of course, engineering design and the safety margin. So statistically it was seen that operational controls are around 51%. So which means, or the corollary is that if we are excellent in our operations, we can reduce the process safety event by more than 50%. There is design integrity of 35%. Mechanical integrity of 35%, I beg your pardon, and then design, which includes around 14%. Those 18 process safety fundamentals which EPSC identified are: double isolation, first line break, flexible hoses, furnace burners, leak tightness, unloading, open drain operating limits, overrides, plugged equipment, critical equipment, reporting, runaway, splash loading, line of fire, utility connections, walk the line, and single valve. So if you just recap or just remember what we just saw, 51% or the 51% contributors towards a process safety event or a loss of potential containment event is because of poor operational practices, and EPSC has now sort of broken them down into 18 process safety fundamentals, and this is what all of them are. We are now going to see on how we could not only understand them, but we remember them as well. So we saw EPSC giving us 18 fundamental ways of performing operations more tactfully so that we don't have a loss of containment. But now how are we going to remember the 18 ones? Well, now nine of those life-saving rules seem to be more easier, is it not? Well, please don't be disheartened or under any sort of an anxiety. Brain mapping doesn't limit itself to 9, 18, 9,000, 18,000 or even millions. Our brain has immense potential and we can do much more than actually we think we can. So before we come to brain mapping the EPSC process safety fundamentals, let's now see a few things. Yeah, since process safety fundamentals is about process safety, let's talk about an operating plant. This, as you see, an operating plant is going through something that we call as a turn down or a shutdown. How do we know that it is under a shutdown? Because of the use of cranes, so many people employ, so use of cranes, so many people on site, there are generators mobilized, there are IBCs, there are scaffolds being put in. So once a plant undergoes a turn down, there is a process called as a startup. The jargon uses PSSR, which is a pre-startup safety review. So once the plant is shut down and once it is started up, this is how it looks like. A serene, silent plant with all its containment in its pipes, delivering us by heat transfer and mass transfer operations the energy that we as a humanity needs. And then once, so now the process, what did we talk about? The plant which was under shutdown or turnaround got started up, PSSR, pre-startup safety review. Once that is done, what do? We leave for home. And yes, that is a Rolls-Royce Phantom. The next subject is about a boiler. A boiler produces steam. Yes, it's a boiler. And how does it happen? By firing it up. Now, please hold on to this thought. Which one? Please hold on to this process of turn down, PSSR, and we go home. And the next thought that we need to sort of remember is about steam generation in a fired boiler or a heater using a fired operation. So now using these two things, those two things were what? A plant which is under shutdown got started up, and once that task is gone, we as contractors leave for home. And then making steam using a fired heater, and it's a fire up process. What was the brain mapping method for LSR? Keanu Reeve matrix. It's a matrix. Alpha Bravo Hotel, activity behavior hazard, activity 3 behavior, those erratic driver 3, and hazard using a work permit system or a work authorization system to control hot work and energy isolation. So using these, now let's see how can we use these functions in process safety, that is shutdown, PSSR, leaving for home in our Rolls Royces, and steam generation. How can we use it in brain mapping to remember the 18 process safety fundamentals coming up next? Till now, we are going to see on how are we going to remember those 18 process safety fundamentals using the approach of a plant which was shut down, started up, and we leave in our Rolls Royce, and the steam generation. So like we said, shutdown, PSSR, and Rolls Royce. Let's look into shutdown, the first thing. So what normally happens in a shutdown or turnaround? It is where we do internal inspections, and why we need to do internal inspection, we have to break containment, open vessels, open flange, isolate those things, test our safety instrumented systems, which are the ESDs, our PSVs which were online, do the required Trevi tests and all that. So here in our example for shutdown, this is a tank which has a drain valve. This is a stretch of piping which is used to transfer contents from this tank to the next vessel. There are valves over here, and there is another small de-inventorying flange or a valve. So for shutdown in our brain mapping, what is the operation we do? We have to possibly do double isolation. We will have to break the flange so that we can de-inventory the section, and the tank which had inventory need to be drained, so slowly the tank gets drained. So what were the processes that we said? We did double isolation over here, we broke a flange, and we drained the particular containment. So double isolation, breaking flange or line break, and open drain. So EPSC, these are the three operational excellence things that we have to remember so that a loss of containment does not happen. And that is about double isolation, first line break, and open drain. All this we mapped to the subject of being a plant in turnaround. Earlier we saw about how shutdown is and how could we map the shutdown activities to remember the first three things of the process safety fundamental for ensuring there is no loss of containment. The next one we are going to talk about is PSSR. What is PSSR? Pre-startup safety review. Let's now see a particular flow sequence over here. There is a pump taking suction. There are a few flanges bolted. There is a tank. There are level instruments, and there's an alarm over here. Since it's under pre-startup, what do we know? Some sort of a turn down or a shutdown has previously happened. As part of a PSSR, a pre-startup safety review, by the word review, the definition is a committee or people sit down, chaired by some process safety counterpart over there, and they see that everything which was under turn down has been reinstated. Let's see this particular example. We have our level instruments, but these level instruments and these alarms and these pumps are not connected. Why? This particular thing has been overridden, override. So when things which were supposed to be there has been removed temporarily for testing, inspection, or any plant maintenance, is called a system override. So during a PSSR, there will be something called as an override charter or systems that were overridden. Then what happens? This has to be brought online. But to bring it online, as part of a PSSR committee, we do something called as a line walk, where we walk across the entire unit to ensure that those systems which were overridden are now reinstated. But the line walk does not just limit itself to reinstatement of the overridden controls. It also looks into whether leak testing has really happened. Here there are flanges, so we do some sort of a leak testing. The bolts have been torqued properly, etc. It's a review to see that a system which was overridden has been reinstated. We verify it in our line walks. So as part of PSSR, we do leak testing as well. Now let's map these three activities. What are they? System override, line walk, and leak tightness. So this is the next three operational excellent things that has to be put forward so that there is no loss of containment. Earlier in our shutdown, we saw 3. Now in PSSR, we saw 3 more, a total 6. Let's do a recap. What did we see in shutdown in our small example? There was double isolation, there was a line break for de-inventorying, and there was an open drain. When it comes to PSSR, there is a system override charter, verification by line walk, and leak tightness. Total of 6 out of 18. So this far we have seen on how a shutdown or a turnaround subjects can be used for our need for mind mapping, how PSSR can be used, and now comes our Rolls Royce. So we were part of a long and hectic turnaround. After the turnaround, we sat in a PSSR review, verified things are well, all of us are happy, plant is now running properly, wells and whistles, all good, and now let's take our Rolls Royce and go home. Yay! So now for this example, let's now see that our Rolls Royce that we were going for, we didn't fill it up with enough fuel, so now we go to a typical fuel station. So this is our fuel station, and we see a fuel station has one valve. There is a flexible hose. So we now go into the fuel station, we engage with the person, requesting him to fill our tanks, and then what happens? The person then starts that single valve. Using the flexible hose, the fuel starts filling. And how do we know where we are? Because we'll have an operating limit or a fuel gauge. So here, use of a single valve, flexible hose, and operating limits are the next three things which EPSC tells us, which is a single valve, use of flexible hoses, and operating limit. EPSC identified that use of a single valve as a positive isolation is not an inherently good practice. Wherever you use flexible hoses for your transactions, please ensure the integrity of the hoses, and operating limits have to always be taken in consideration vis-a-vis the age of the plant. So now, using our Rolls-Royce going home, the next three things have been mapped, which is about a single valve, flexible hoses, and an operating limit. So guys, using the analogy or mapping our shutdown turnaround or PSSR and our Rolls-Royce, we have actually finished halfway. 9 out of 18 is done. Let's do a small recap, yeah, why not? The more we wrote, the better we remember. During a shutdown and turnaround, gents and ladies, what normally happens? Double isolation, break flange for de-inventorying, open a drain valve and it's drained. PSSR, what does it happen? There is a system override. We go use our line walk to ensure things are in place, and of course, how can we forget the leak tightness? Our Rolls-Royce, unfortunately the fuel was low. We go to a fuel tank, we start the fuel valve using the flexible hose. We can see how much our tank is full, and that was our operating limit. Using the mind mapping and thinking about the sequence of shutdown, startup, and going back in our Rolls-Royce, we have seen 9 process safety fundamentals which, if reconciled, remembered, and put to practice, what EPSC says is that and what even I believe, we can reduce the process safety incidents or a loss of containment to happen. So now, having very effectively mapped 9 of our 18 elements using the analogy of a plant under shutdown, starting up and going home in our Rolls-Royce, now let's come to the next 9, and for this we need to look into our steam generation superheater. Let's start with steam. So we have a steam system, and steam in our plant is normally used as a utility. Steam, there are high pressure steam, medium pressure and low pressure steam. Any pressurized line needs what? Yes, it needs a pressure safety valve, relief valve, or a temperature relief valve. So that is a critical equipment in our steam line. For all those of us who are in plants, one thing which we always have is plugging of our steam traps. Our steam traps gets plugged. Now let's mind map these things to generate our next 3 process safety fundamentals. So first one is utility connection, next one is critical equipment. So the PSV was our critical equipment, and the third one was about plugged equipment. So now moving with our next 9, and we just completed 3. We are using the analogy of a steam generation. Steam is a utility service. Being a pressurized service, there is a critical equipment which ensures the integrity of the steam line as a PSV, and all of us have plugging issues, and steam traps usually get plugged if we don't maintain them on time. We just saw about steam. Now, how is steam being produced? Steam is produced in a boiler or a fired heater. So what are the functions that normally happen in a firing of a heater? Now let's take this as our example for a fired heater. It's a fuel gas driven heater. The sequence is that First, we will ensure that there is a flammable atmosphere, the fuel gas has been put in, there is oxygen, the stoichiometry is monitored, then we fire it up, we have a controlled combustion, and then the heater starts working. But let's say because of some misfire, we lost the particular combustion, so normally what happens? We start the refiring of the heater. Unfortunately, what happened, the operators did not really look into the flammable atmosphere inside. It went a little bit above the flammable limit and it was an explosive atmosphere. Unbeknownst to the operator, he fired it. What will happen? It goes to a runaway reaction and it happens a runaway reaction. Here is an uncontrolled combustion, which is an internal explosion. An internal explosion, a process safety event happens, and when something of this happens, we all know that that particular accident or the incident is reported. So we saw about steam. Steam was through a fired up heater. The fired up heater, what did we see? What are our mind mapping things to take away from here? It is about the firing sequence that we saw, and the firing sequence, if not made judicious, can go for a runaway reaction, which was our mind mapping internal explosion. And when an event happens, that needs to be reported, recorded, and investigated. So let's now map those three events. It is the furnace burners firing methods, it is the runaway reaction, and reporting. So in our fired heater, we saw that the firing sequence, if not done properly, can lead to a runaway reaction, and when such of that thing happens, the incident needs to be reported. So these are the next three. Please don't worry if you are feeling a little bit anxious on how are we going to remember it or how are we going to do all these 18. We are halfway and it is going to be made more easier as we go through the next part of the video. So the 18 elements, let me just say that we are 15 down, now only 3 more to go. We saw the steam, we saw the boiler, and now what is remaining? Fire. For matters of our brain mapping or mind mapping exercise, let's think about a fired arm. Fire, fired arm. So those who have used it knows that while we have to use it, we need to go to a firing ground as part of the training or a firearm range. So over here in this firearm range, we can see this person and the target is in the line of fire. So first one is line of fire. Once we run out of our magazine, we need to unload more bullets into the magazine, and the next thing that I want you to map is something which which we all in a society is going through, is about suicides, where people actually commit suicide by firing themselves to the brain and splashing their brain out. I do realize that this might not be the best example to give, but then for the purpose of our mind mapping, I have, or let's say for greater good, I have used this example. So what did we see? We see in a firing training ground where in the line of fire there was loading and unloading of the firing arm and then splashing the brains out. Let's map these three things for our last of the 18 elements, the last three things of the 18 elements. That was about line of fire, loading and unloading operation, and about splash loading. Here what EPSC says is that operations should always ensure that whatever activity you are doing, you are not in the line of fire. For example, this particular operator who is trying to dislodge a valve is towards the line of fire because the containment is pressurized. So in case if it flies off, we can always think that yes, there are retainers over here, but who knows the integrity? So this person is in the line of fire if it comes out. Then about loading unloading operations, we must have heard about, or in CSB there are a lot of videos of filling operations, like acid being filled to an alkali tank during loading and unloading operations. And the other thing of having a static discharge while doing loading is about splash loading. So these are the three things which are the last three of the 18 which EPSC talks about, and we tried to map it in terms of the firing range, line of fire, cocking the gun to load and unload more bullets, and then suiciding by splashing our brains. So these are the next or the last three ways of remembering or brain mapping or mind mapping the 18 elements. Now, using our steam system, steam, fired heater and fire, let's now do a recap, a cumulative recap. And it was about the steam system. Steam is a utility service. PSV is a critical equipment. We always have phased plugging. For the fired heater, the firing sequence is such that there is a flammable atmosphere. You try to heat it. Because of a misoperation, there was an explosive atmosphere that went to a runaway reaction as an internal explosion that needs to be reported and recorded. And the last is about being in the line of fire, loading operation, and yes, splashing the brains and killing yourself. So these are the other 9 of the process safety fundamentals. For all those of us who have come this far of the video, please pat yourself and congratulate, because we have finished all the 18 elements and we have seen on ways on how to map it. Let's look at it once again right from the start. So we talked about shutdown, PSSR and our Rolls Royce. And in shutdown, what happens? There is double isolation, there is flange crack and for de-inventorying, and then we open the drain valve. For so that is the first 3. For PSSR, what do? We have a system override tracker. We perform line walks, and there is of course leak testing. That is the next 6. For our going back home, we pull over to a fuel tank, a fuel station and the kiosk. We open the valve. Using the flexible line, we can monitor how much of the fuel is there in the gauge, because we have operating limits. These are, and this is the next 3 summing up to the first 9 of our process safety fundamentals. Trying to map using the steam circuit. Now let's look at all the 3 again. It's about steam is in a utility service. PSV is a critical equipment. There is always plugging. So this is the 12 elements of the EPSC. Firing heater, the sequence of misfiring leading to a runaway reaction, and that leads to an incident reporting, tallies to 15. Last and the least, line of fire, loading operation and splashing the brains out as the last and the 18 elements. Before we summarize the 18 process safety focus areas which EPSC has defined, may I please ask you all to kindly pause the video again, and just like we did for the LSR 9 elements, could you all please go through our mind mapping of the shutdown, PSSR, Rolls Royce and our steam circuit, and try to engage and fish out and memorize how many of the 18 could you remember, and please write down in the YouTube video and let me know. Why I am asking you all to let me know this feedback is just to know how much has this been relevant to us, because then I can take it back to my area of work and try to bring it out to the people, so all of us can work towards bringing a safer plant. So here again we will be working in the Keanu Reeves metrics. So it is about operation shutdown, PSSR and the fuel. So please lip sync with me, what are these? Double isolation, line break and open drain, PSSR system override, line walk and leak tightness. use of a single valve, flexible hoses, and of course operating limits. This is the 9 ones. The next 9 we have seen: steam system, a boiler system or a fired heater and fire. Steam system is a utility, critical equipment and plugged system. For fire we have line of fire, loading, unloading and splash loading. Boiler, the furnace heater, operations, runaway and reporting. Using mind mapping, we have tried to push ourselves, or we've now realized that 18, 80 or how many we can always use mind mapping to remember, because if you remember you can reproduce, and if you can reproduce this you can potentially work towards making a safer plant. We now come to the end of the video about life-saving rules and process safety fundamentals. The credits go to IOGP and EPSC for formulating all this. I've taken a few pictures from internet. And now coming to the Simon Sinek's golden circle, the why, how and what. For those who have possibly seen a few of my videos must have noticed that I don't ask for liking, subscribing, sharing and all that. The why of my video is because I believe that education is a birthright, and this is my way of democratizing free learning and the learning towards process safety and loss prevention. How is this going to improve? It is going to improve, I believe, that people who look at it, take away few from it, start discussing about this and spreading this message across their peers. And what do I aspire for? I aspire to let everyone know that having a YouTube channel, using internet to spread your message is not that difficult. It only needs consistency and using some of your time for a greater good. In my channel, there is always something called as an attitude for gratitude, and this here that you see is Mr. Chandramohan, whom I very lovingly call as Babu Uncle. He is not in this world anymore with me. In my very initial video, I did happen to talk about my parents, where I aped what Abraham Lincoln said, that all I am and all I ever hope to be is because of my parents. But Babu Uncle is one person in life who influenced me in more ways that I can say now, is when I was down in the dusk, where people were judging me, where people saw me as a failure. Babu Uncle just took me under his wings and then made me realize and made me resilient and growth minded. If not for Babu Uncle, possibly I wouldn't have come this far or this close in my career. Thank you very much, Babu Uncle, and you all. Thank you for your patient listening. We will meet again.